Here's the second section of chapter 5. Last time we were talking about completing the square, and it seems like we always move over that C. We always move over that C every time it's already moved over for us, right? We make sure A is equal to 1, which it is. That's a 1x squared. And then we go ahead and do the process of adding a new C, and we add it to both sides. And that new C is always B squared, or not B squared, sorry, B over 2 quantity squared, and we add that to both sides, which ours would be 14 divided by 2, which is 7, and then 7 squared, which is 49. So we'd add 49 here and add 49 over here. So we can add 36 and 49, which is 85. Alright, and then we get x squared plus 14x plus 49. Right, that 14x doesn't change. It doesn't disappear just because you took your b and divided by 2 and then squared it. It doesn't actually literally change the b. The b stays the same as 14x. You're just finding that new c to go right here. And then we simplify, right? We factor this quadratic side, and it's always going to factor your x plus your b over 2, which our b over 2 is 7. 14 divided by 2 is 7, and then quantity squared equals 85. And then if we're solving, then we go ahead and square root both sides. If we're not solving, we're finding the vertex, then we just subtract on this side, and we get the quantity squared, and then plus some number minus some number here. It's going to be minus 85 equals 0. And then we change 0 to y, and now we have our vertex negative 2 comma negative 85. But if we're asked to solve, then we actually square root both sides to get rid of square root and squared cancel out, so we just get x plus 7. And over here we get square root of 85, which I don't know the top of my head, but I can use a calculator to figure it out. And then when I do that, I get a positive square root 85 equals x plus 7, and then I get a negative square root 85 equals x plus 7. Now I solve for x by subtracting 7 on both equations. Notice how that plus 7 doesn't change on both equations. It's actually the same. The only thing it changes is the square root. I have a positive square root and I have a negative square root. So this is minus 7 plus square root 85 would be my answer for x here. And then minus 7 minus 85. So see how that negative 7 is both the same on both of these? Oops. That square root needs to go inside. Negative square root 85 equals x. So those would be my two answers there. Alright, so what I want you to do here is I want you to take this equation and follow the steps to solve. So I want you to take this equation where your a is already equal to 1. Okay? You have a bx plus c equals 0. And I want you to solve this for x. Because if you can leave b as the letter b and c as the letter c with a equal to 1, which it is, then you would have a formula at the end that would allow you to not have to do those steps anymore. So if you can do it more generally, right, because b can be any number and c could be any number, and if a is 1, then you could have a formula to solve any quadratic where a is equal to 1. So you could have a formula that would allow you to solve it for any number of a b and any number as a c, as long as a is equal to 1. So then all you have to do is just enter those numbers into this some formula down here, and you would have your two answers. So go ahead and try that. And I'm going to let you do that on your own. I'm not going to do it for you. So you can pause the video and do that now. So it turns out that when you do that, it's really nice and it goes kind of quick. Well, there's actually something that we're going to learn about today is the quadratic formula. It allows us to solve any quadratics even when a is not equal to 1. And here is that formula. So here's that formula where a is not always equal to 1. Just a can't be 0, or it's not a quadratic anymore. So here's your example. Here's the formula. It's called the quadratic formula. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. And I would get in the habit of memorizing that and have that down so you can do it. So then all we have to do is identify what's your a, what's your b, and what's your c, and then we can plug those in here. Like this example right here. They identify what the a is, the b is, and what the c is, and then they plug those in to where they go. There's the b, there's the a, and then there's the c. And then you simplify this. You simplify the inside of this first, right? So I simplify the inside of this first, then you take the square root, Then you take your negative b and you add that square root. And the very last thing is you divide by 2 times your a. And then you have to do it again where you're taking your negative b and then you subtract that, whatever the square root of that number is, and then you divide by 2a. So you're always going to have 2 answers. So that is called the quadratic formula. So let's go ahead and practice that now. Okay, so here's my equation. We're going to use the quadratic formula. Okay, so steps. Here's the steps. So step 1 would be set one side equal to 0. So that means this side I can move this over negative x, or negative 2x. Now I can't subtract that from x squared, and I can't subtract it from negative 8, right? So I just add it to be a quadratic. Equals 0. Because I need an a, b, and c. That's step 2. Find a, b, and c. So here my a is how many x squareds I have, which is 1. B is how many x's, plain x's I have. That is negative 2. Remember, the negatives are very important, so if you leave off the negative, your answer is going to be totally off. Okay? And then your c, which is your constant, the number without the variable. Again, the negative's important, negative 8. Okay, and then step 3. Plug in a, b, c into the formula and solve or simplify. Okay, spelled simplify wrong, but that's okay. Alright, so now we have our a, b, and c, and now we're going to plug them in a formula. The formula is x is equal to. So see how it says x is equal to? Because we're solving for x. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's good to have like a little rhyme. I think it goes to row row your boat or something like that. The tune goes. So now there's the formula. So now we're going to plug in our a. So I have an a here and an a here. So let's do that. I'll do this one at a time. Actually, I probably should just do it with the same color. So there's my a. I would recommend whenever you plug in a number, substitute a number, you use parentheses. C all over 2a, which is 1. Plug in my a. The more tedious you are, the more time you take, and the more you take care to do this, to plug in and make sure you do every little thing right, you're going to have less problems later. Yes, it takes more time to do that, but the more precise you are, you're going to get the right answer. If you don't pay attention as much and you're not focused when you write stuff down, you're sloppy, you're trying to just go really fast, you're probably going to get the wrong answer. The more slower you go doing this, after you do it a while, then you can get faster and faster. Okay, you don't have to do what I'm doing right now, entering every little thing and then writing every little thing. You can all plug in your A, B, and C all at once. That's fine. I'm just doing it slow so you can see what's going where. So I'll keep the main equation in black. Now I'm going to plug in my B. So that's a negative B. My B I'll plug in as negative 2. Then plus or minus square root. So everything in black always stays in there. The only thing that changes is the different colors. Then I plug in my b, which is negative 2, and that's being squared. So my negative 2 is, or my b is always being squared, so that's why the squared is in black here. Then it's always minus 4. Okay, that doesn't change. I plug in my a. I want to do my a's in red. And c I don't have yet, so I'll keep that in black for now. And then all over 2 times my a, and my a is in red. Okay, so that's me plugging in my a and my b. Now I'm plugging in my c, which is negative 8. Okay, so everything in black stays like it normally is. It doesn't change based on the number. So it's always a negative. Negative your b, and plus or minus the square root of your b squared minus 4 times your a times your c all over 2a. So maybe if you want to write it like this every time, like when you write the quadratic formula, write it with this, like with those parentheses, exactly like that. And then you just plug in your b, which our b was in blue. And then plug in your a, which our a was in red. And then plug in your c, which we'll do in green. Okay, -8. So there you go. So if you write it in that format, that kind of outline, then you can just plug in your numbers. Now remember, we kind of want to do, oops, sorry. We kind of want to do the inside, what's inside the square root first. That's the very first thing. We want to do what's inside of there first, okay? And remember, whenever you square something, it's always going to be positive. So sometimes you'll type in the calculator -2 squared and you'll get -4. That's not true, right? Because a negative times a negative is a positive. Okay, so whenever you square this, whatever that number is, you will always get a positive here. So let's do what's inside that square root, okay? So let's take apart what's inside that square root, and let's simplify that. Okay. Alright, so I want to take this apart real slow. I'm just doing what's inside the square root to begin with. Okay, so -2 squared is 4. Okay. -4 times a times c. There's my c, there's my a. Now, this is all multiplication, right? So before I subtract 4, I have to multiply, right? I'm doing my order of operations, so I took care of my squared first. Now I do my multiplication in here, right? So that's -4 times 1 is -4. -4 times a -8. Okay, so -4 times a -8, that's a positive 32. And I'm adding my 4 from my b squared, which is 36. So now I have 36 here. Okay, so that is just what's underneath the radical, right? That's just this part. So now I have put everything else back in. So that's x equals my -b plus or minus the square root of all that stuff that I just did, all over 2 times my a. My b was -2. My a was 1. Okay. Now if I can simplify my square root here, then go ahead and do it, which we can, right? Square root of 36 is 6. The plus or minus is already there, so if you want to, you could literally write 2 equations instead of just one to begin with. It could be x equals -b plus the square root of b squared minus 4ac all over 2a. And then you have a second equation, x equals -b minus the square root of b squared minus 4ac. Sorry, I'm running out of room there. All over 2a. Right? So there's literally 2 things going on here. So let's go ahead and complete it. Square root of 36 is 6. And then we have, then we have plus and, plus and minus -b, then it's all over 2 times my a. So you want to simplify that root as far as you can first, then you can go ahead and deal with the other stuff. Okay, so now we can do a -2, that is a +2, then plus or minus 6 all over 2a. Now we can simplify. A lot of this you can do all at the same time. I'm just going real slow about it. Okay, then 2 plus 6, or I can simplify the 2 times 1 on bottom, so let's simplify that. Plus or minus 2 times 1 is 2. So we simplified everything that we can simplify, and again it is x equals, right? X equals, x equals. Now there's 2 equations here, so if you want to, you can do 2 equations here. We have x equals 2 plus 6 all over 2, and we have x 2 2 minus 6 all over 2. So I have to do the top first before I divide by 2. The very last thing is you want to divide by your 2a. So the very last thing I do is division. So I'm going to do 2 plus 6, which is 8, divided by 2. 8 divided by 2. And this one would be 2 minus 6, which is a negative 4, divided by 2. So now the very last thing I do is I divide by 2, and I get x equals, and I get 8 divided by 2, which is 4. Negative 4 divided by 2, which is negative 2. And so those are my final answers. That's how you use the quadratic formula. It was slow and meticulous. Some of you guys are going to be really good at it. You can just plug it in and do it, a lot of it in your head, and that's fine. But this is a way to solve all quadratics, no matter what A you're given, no matter what B you're given, or no matter what C you're given. You can solve all quadratics this way. I would just recommend that you could write it as 2 equations like I did there. You can write it as 1 equation like I did here, and then you can just do your outlines like I did on both of these, just the outlines with the parentheses. But always take care of what's inside the radical first. So what's inside the radical underneath the square root sign. Do that always first. And remember, whenever you square a number, when you square your b, well, no matter if b is negative or positive, you will always get a positive. And also that negative 4 is always in there. Regardless of what numbers you have, that negative 4 is always in there. Okay, so go ahead and try this one. All right, step 1, set one side equals 0. Equal to 0. Step 2, find A, B, C. Step 3, plug A, B, C into formula. And then you're done. And then you'll find your x. So go ahead and pause it, try it. I want to do it, and I'll do this one probably pretty quick. So I'm going to just do my outline first. Negative b plus or minus the square root of b squared minus 4ac all over 2 times my a. Now I want to enter in my a, which is 1 because I have 1x squared. So 1 here, 1 here. Now I'm going to enter in my b. My b is negative 4, so I'll enter that here and here. Now I'm going to enter in my c. But what's different about my c? Well, one thing, this is step 1's not done, right? This is not set equal to 0, so I need to subtract 21 on both sides. Now I have my c. It's actually negative 21 is my c, not positive 21, because I need one side to be equal to 0. So I need to move that number to the other side, and I get negative 21. So my c is negative 21. Okay? Now I can go ahead and start simplifying. We can just take, if you want to, you can just take what's inside the square root here and just pull that off to the side. Pull this off to the side and do it on your own. Just do it off to the side. And then I'm just going to do it in purple here. So negative 4 squared is 16. negative 4 times 1 is a negative 4. Negative 4 times negative 21 is a positive, right? Because I have 2 negatives here, that's going to make a positive. If I had 3 negatives, it would be a negative. If I had 1 negative just right here, if this is the only negative in this list, then I would be subtracting here between the b squared and the right side. But if there's 2 negatives in this list, then you're going to be adding. If there's 3 negatives, then you're going to be subtracting. So because there's 2 negatives here and here, that means that I am going to be adding. Because negative 4 times negative 21 is 84. So 84 plus 16, that is 100. So that's what's going to go underneath the square root, right? That's what's going to go underneath the square root over here. Underneath the square root. So 100 is underneath the square root. So we have our x is equal to negative b plus or minus the square root. We know that answer now. 2 times our a. Our a was 1 again. Our b was negative 4. And now what was underneath the square root was right here, so let's put 100 underneath there. Now we can go ahead and simplify. What is the square root of 100? Well, the square root of 100 is 10, right? So the square root of 100 is 10. And the plus or minus takes care of the plus or minus. So we don't need to write plus or minus again. It's already there. The formula takes care of that. Then we have our a, and then we have our b. Now we can go ahead and simplify our negative b. So that's a negative negative 4. So that's a positive 4. Then we have plus or minus 2 times plus or minus our 10, square root of 100. All over 2 times our a, which is 1, and now 2 times our a. Oops, I know that answer now. Oops. Erase. So now we have 4 plus or minus 10, so that means 4 plus 10, and then divide by 2, because 2 times 1 is 2. And then do 4 minus 10 all over 2. So really there's 2 equations. I'm going to stop using 2 different colors because it's kind of taking a while. So 4 plus 10 all over 2, and then 4 minus 10 all over 2. So I add 4 plus 10, which is 14 over 2, and then I do 4 minus 10, which is a negative 6 over 2. So the very last thing I do is divide. So x equals 7, x equals negative 3. So those are your answers. Alright, so here's a more complicated problem, but here's a word problem, application problem, whatever you want to say. But look, there's our equation, so probably it's going to ask for our solutions, right? But what is our solutions to here? This is a parabola. You're throwing the ball, and it probably wants to know how far the athlete, how far from the athlete will the ball land. So we're looking at trying to figure out where does it land. This is the equation that tracks the ball. It's a shot put. The arc of the ball can be modeled by the equation. So this is the arc of the ball where you have your distance and your height. Okay, so x is the horizontal distance in meters, and y is your height. So how far the ball is up, and then how far does the ball. So we want to know when it lands. Well, what's the height when it lands? Well, isn't that 0? So my y, my height would be 0. So this would be 0 is equal to negative 0.04x squared plus 0.84x plus 2. Well, doesn't that look like this equation right here to start? Well, not quite that equation. Once step 1 is done and it's set equal to 0, don't we now have a quadratic, oops, x plus 2, don't we have a quadratic squared equal to 0? So step 1 is kind of already done for us. Now we can find our a. We can find our a, which is negative 0.04. We can find our b, which is 0.84, and our c, which is the constant, the number without the variable, which is 2. And now can I enter that into our quadratic formula and find our x where it hits the ground, our distance where it hits the ground. And again, you're going to have 2 answers, right? One answer is going to be back here. Let me do black. One answer is going to be back here, so that's going to be negative, right? So we can throw that out because you're not going to throw it backwards. It's throwing it forwards, right? So we can take the positive answer. So there'll be one negative answer here and one positive answer here, and we can throw out the negative answer. Okay, so let's go ahead and do this. We first form our outline. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So when I say throw out the negative answer, that means I don't just erase this, because maybe that is going to be our actual answer, right? Maybe the positive one is going to get us a negative. It just depends on how big our numbers are in here. Okay, so let's go ahead and fill on our a, b, and c. Here's our a, negative 0.04, negative 0.04. Our b, which is 0.84, 0.84. Here's where you got to take a calculator. And here I can show you in class how you can enter this actually on your calculator. Just like this outline, I can show you how to enter that outline on your calculator, and then you can just hit enter, and it'll give you the answer. And then you have to come back and you have to change, because you can only do one of these at a time on your calculator. It can't do plus and minus. So you'd have to come back and enter it. Now we can enter in our c, which is 2. Okay, so I'm going to go ahead and pause the video and find out what these numbers are so then I can save them. Okay, so here I did each of these kind of one at a time. So I did my b squared, I put it in my calculator just like it looks, just like that, with the parentheses, 0.84 parentheses, and hit the squared button. Got my answer, 0.7056. Then I did all this just like this on my calculator, my negative b times my a times my c, just like that on my calculator. That's the answer I got. Then I did 2 times my a, just like that on my calculator. That's the answer I got. Now I'm going to take those numbers. I'm going to take this one, and I'm going to take this one, and I'm gonna, because those are both positive, I'm going to add them, right? If this one's always going to be positive right here, this one could be negative, and if it's negative, then you subtract these two numbers, because remember, it's b squared minus 4ac, right? So that means these two terms, you're adding or subtracting these two terms, okay? So since they're both positive, I'm going to add them, and then I'm going to rewrite those, and so that's what would go underneath the square root. Okay, this b squared minus 4ac, that goes underneath the square root. So we can go ahead and add those together, and that is 1.0256. That's what's going to go underneath the square root. Then I have the plus or minus my negative b, which was negative 0.04, and then all over my 2a, which is negative 0.28. Okay, so now a negative b would be a negative 0.84 plus or minus the square root of this 1.0256 all over negative 0.28. So now I'm going to do this in my calculator alone. Okay, so I'm going to enter that in my calculator and see what I get. And I get, here you can round to whatever it says. Let's round to the hundredths place. And I get 1.01 plus or minus my negative b. Oops, point's right here. Let's erase that point. All over my 2a. So that's what x is equal to, and my 2a was negative 0.28. So now I have two equations. I have x is equal to negative 0.84 plus 1.01. 0101 all over negative 0.28, and then I have x is equal to negative 0.84 minus 1.01 all over negative 0.28. So you could do these both and see which one's negative and throw that negative one out, throw that negative answer out, and then just take the positive. Or you can see here, notice that, hey, I have a negative minus more negative. So if I borrow money and I borrow, if I borrow 84 cents and then I borrow $1.01, I'm still going to owe money. That's a negative, and what's a negative divided by a negative? That's a positive. So this one right here is actually going to give us the positive answer. Okay. So we don't even have to do the one to the left, but I'll go ahead and do it anyways, just so that you have that practice of doing it. Okay, so if I add my top, I get if I take negative 0.84 plus 1.01, I get 0.17, and I'm going to divide that by negative 0.28. Okay, so that means a positive divided by a negative, so that means I'm going to get a negative answer, right? And I get negative 0.61 approximately. Okay, and that's a negative answer, so that's going backwards. All right, that would be a backwards distance because that stands for the distance. So that means we need to do this top one where we take a negative 0.84 and we subtract a 1.01, which gets me a negative 1.85, and then I'm going to divide that by negative 0.28, and a negative divided by negative is a positive. So that's why we're taking this answer to the right, because it gives a positive distance there. And so we get 6.61. 6.61. And so that is the distance, how far he throws the shot put. Okay, here's another one. Same thing. This one's a baseball. So hitting a baseball, and this is the model of the path of the ball. We want to figure out how far the batter hits the ball when it lands. So that'd be setting this y equal to 0 here, and then using the quadratic formula. You're probably going to have, because the ball comes like this, hits off the bat. Well, you don't hit the bat off the ground, right, or the ball off the ground, right? So that means this area back here, the parabola, is you're going to have a negative answer when it hits the ground, and then over here you'll have a positive answer. That's the one we're looking for, right? So you can do this on your own. I'm actually not going to do this at all. So you can go ahead and do it. I'll just write the answer down, what it should be, and so you can check yourself. So the answer should be 144 feet, 144.8 feet. That should be your answer. Okay, so here's some of the different methods and when to use them, right? So methods of solving, right? To solve quadratics. Okay, so one way is graphing, and we use graphing usually just when we have a graphing calculator handy. Okay, so there's or if we have graph paper. But the other ways are pretty much better. Okay, square roots. We use square roots when there is no x term, no b. When b is gone, we can solve by square rooting, right? We move c to the other side, so our x squared and our c is by itself, and then we can, if we need to divide by a on both sides, we divide it by a on both sides, and then we square root both sides, and we have a plus or minus answer. Okay, factoring. We only do factoring when our equation is easily done. We can factor it easily, right? We know we can just do, if maybe we just have x squared, just x squared, right, by itself, then we can try to factor it, and we just do cab, right? Or if we do have an a in front, we can do cab. If cab is not easy, then stop doing cab and move on to completing the square. And we only do completing square when we just have an x squared. When x squared is, when our coefficient, when our a is equal to 1, then you can do completing the square. But if the a is not 1, then we kind of want to move on to this quadratic formula. And every quadratic formula, it's a formula for all quadratics, so any quadratic will work in the quadratic formula. Okay, so that's kind of the methods and when to use them. I'll say go ahead and do this problem, see which was the easiest method. By graphing, you don't have a graphing calculator probably, so throw that one off the board. Square rooting, completing the square, factoring, and the quadratic formula. Whichever one's easiest for you to do, basically. That's kind of the probit method, basically, is which one's easiest for you to do. So I'm going to go and do this one. So this one we have no b, so I'm going to add 9 to both sides. Because there is no b, then I'm going to divide by my a, and then I want to square root both sides because I'm trying to get x by itself, right? I'm solving for x. And whenever I square root a number, I have plus or minus 3, so there's my answer. I have x equals square root 3, and I have x equals negative square root 3. That negative's on the outside of the root. So those are my two answers. Okay, you can go ahead and try this one. This one we do have a b, so therefore you can pause the video because I'm going to go. This one does have a b, so I can try to factor it first, right? So I want to factor it first. This one cab, my a is 1, so that's great too. So I look what times what is 30, but adds to 1, basically, right? My cab CA is negative 30, and since that's negative, we're really going to subtract to the middle, so we're subtracting to get to negative 1. But we can think about this as just in terms of positives. So what times what is 30, but subtracts to 1? Well, that's 6 and 5, right? 6 and 5, because 6 minus 5 is a 1, right? Is 1. But I need a negative 1, so I need to switch this sign. So that means I need to switch places with that 6 and 5. Let the 6 be negative. So x minus 6 and x plus 5 is this side. Now the left side equals the right side. The right side is 0. And now we're saying what times what gets me 0, right? So here we're trying to figure out by setting these binomials equal to 0. So I set what's inside the parenthesis to 0, and what's inside the parenthesis to 0, set both parentheses equal to 0, and then solve for x. We kind of did this last semester. So this one you subtract 5 on both sides, and you get minus 5. Once you find these numbers, isn't it just my answer just the opposites? Right? Once I find those numbers, as long as my a is equal to 1, then I can just take the opposite, and those are my answers. Okay. Okay, go ahead and try this one. This one's a little more difficult. You pause the video. It's set equal to 0, which is great. Here my a is not 1, so I probably want to do quadratic formula, right? Which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I can plug in my b, since it's set equal to 0. I can plug in my a, and I can plug in my c, which is negative 17. Negative 17. Now I can do the inside of the square root, right? 13 squared is 169. I'm just going to take what's inside the square root and kind of do it off to the side here, right? Your negative b, your b squared minus 4ac. I'm going to do that off to the side. So b squared is 169. Then I got a negative 4 times my a times my c. So I'm going to do that by itself and see kind of what we get here. And we get 408, we get a positive, right? Because we have 1 negative, 2 negatives. So we have a positive, put a plus sign there, 408. And we're going to add 169 to it because that's our b squared. And that is what's going to go underneath the root. So underneath the root is 577. Okay, so not just 577, it's not plus or minus 577, it's plus or minus the square root of 577. Alright, now we have x minus our b, x equals a negative b, so that'd be a negative 13. Negative 13 plus or minus the square root of 577 all over 2 times a, so 2 times 6 is 12. Okay, then I'm going to take a calculator and figure out what 577 is. I'll show you later in the next section how to actually solve that there. Just simplify it. Okay, so we're going to take the square root of 577. We're going to round it to the hundredths place. So that's 24.02. And that's plus or minus that, minus 13, plus or minus that, all over 12. So now we got to take negative 13 and add 24.02, and then divide by 12. And that's going to be 1x. And then my other x is going to be negative 13 minus 24.02, all over 12. Okay? So here we get negative 13 plus 24 is 11.02 all over 12. Which is 9.92. And this one I'm going to take negative 13. I'm going to take negative 13 and I'm going to subtract 24.02. And I get negative 37.02, and then I'm going to divide that by 12, and I get x is equal to negative 3.085. And so that is my answer, and that one is my answer. Okay, you can go ahead and try this one if you want. So here we can try to factor this, right? It's not going to factor, because what times what is 3 but adds to 5? Nothing. So you could do completing square, but this is an odd one. Whenever you have an odd b, it's kind of hard to complete the square, but you still could complete the square, but you're going to use decimals, and if you're going to use decimals, you might as well do quadratic formula. So here you want to do quadratic formula. My a is 1, my b is negative 5, and my c is 3, because it's set equal to 0. So we have a negative b plus or minus the square root of b squared minus 4ac all over 2 times our a. We can enter in our a, which is 1. We can enter in our b, which is negative 5, negative 5, 5, and then our c, which is 3. Take care of the inside of the square root first. So we have our b squared, which is 25. We have our negative 4 times our a times our c, and I can enter it just like this, as long as that is a negative and not a subtraction. In your calculator, you can enter it just like this, and you'll get the answer of negative 12. So now we're going to add these together, okay? So if you want to, you could actually just put a plus negative 4 there, if you want to. So you know you're always going to be combining this one and this one always together. So 25 minus 12, that's 13. So then we have 13 is underneath the square root, plus or minus a negative 5 is a positive 5, and 2 times 1 is 2. So there we have our quadratic formula so far. 5 plus or minus square root 13 all over 2. So I'm going to find out what the square root of 13 is. And it's 3.61, 3.61-ish. I'm rounding to the hundredths place. And now I'm going to take 5 plus 3.61 and then divide that by 2. So that is 8.61, 8.61 divided by 2. Four point something? 4.3305. So that's one answer. Now I'm going to take 5 and minus 3.61. 5 minus 3.61 is 1.39, and then I'm going to divide that by 2. So x is equal to 0.695. So there's my second answer. Okay. All right, so go ahead and do this one any method you want. Okay, here 12, what times what is 12 but adds to 8? That's 6 and 2. But since this is negative, my b is negative. Since my b is negative, that means they both need to be negative here. And since my a is 1, I don't need to divide these by a, so my answers are basically just opposite, 6 and 2. But I can write this equals 0 because this equals 0, so the two binomials will equal 0, so set those binomials equal to 0. Add 6 on this one, so x equals 6, and add 2 on this one, so x equals 2. Okay, so what we've been doing, the first thing when we use quadratic formula is we've been finding what's inside the square root. Well, what's inside the square root is called the discriminant. And when you find a discriminant, when that number is positive, what happens is you have two real number solutions. So you have two real solutions. So that means you're going to get like negative 1/3 and negative 2, or positive 2 and 5, or negative 3 and negative 5, and you'll have two answers. Okay, you'll have two answers if what's underneath the square root is a positive number. Okay, well, what happens when that is equal to 0? Okay, when that is equal to 0, what's inside the square root? If that is equal to 0, oh jeez, when that is equal to 0, what happens is you get an answer of the square root of 0. Well, what's the square root of 0? It's not plus and minus, right? It's not plus and minus 0. Square root of 0 is just 0. So you will have one solution. You have one real number solution. You have one solution. It's fine. Okay, so just because when you square root 0 doesn't mean you have 0 solutions. It means you have one solution. Because when you square root 0, you'll just be taking your negative b and adding 0 and then dividing by 2 times a. Well, what's negative b plus 0? That's just negative b. So your answer is just negative b over 2a. So when your discriminant is 0, what's underneath the square root is 0, the number underneath there, then your answer will just be negative b over 2a. And you'll have that is one answer, right? Okay, the last thing is if your number is negative. If your number is negative underneath the square root, that means you have no real number solution, no solution, or at least no real number solution. We'll get in the next section what that means. That's when our graph is above the x-axis. All right. On when it equals 0, that means it touches the x-axis just once. When we have two real solutions, that means it is below, it crosses the x-axis twice. All right, so go ahead and use the discriminant. So all you have to do is just the part that's underneath. So we don't even care about the square root here. All we care about is what is underneath the square root. So we're just doing b squared minus 4 times our a times our c and seeing what is that. Is that number positive? Is it negative? Is it positive? Is it negative? Or is it 0? Okay, if it's positive, that means we have two real solutions. If it's negative, we have no real solutions. And if we have 0, that means we have one solution. Okay? So, and remember, if you want to, you can put a plus in front of this. Maybe that's what I'll say in class. Plus negative 4 AC. And maybe I'll do this. Maybe I'll show that in class. So then you're always adding here. Okay, so my A is 2. My B is, I believe, -3. Make sure it's set equal to 0. This one's not set equal to 0, but my B is still -3. Okay, but my C is on, it's not set equal to 0, so I need to add 5 to both sides. So my C is actually +5. So make sure you don't get tricked by that. Okay, so then we can go ahead and -3 squared is always going to be positive, right? Negative is always going to be, when it's squared, is always going to be positive. And then take -4 times 2 is -8. -8 times 4 is a -40. So 9 plus -40, that's a -31. So we have no real solution. Okay, so that's how you do those. So go ahead and try this one by yourself. Make sure it's set equal to 0. This one's not, so make sure it's set equal to 0. And now I'm going to do it. Go ahead and pause it and try it by yourself and come back. Subtract 7. So that means my A is 6, my B is -5, and my C is -7. So then I do my B squared, and adding my -4 plus my C plus my A times my C times -4 there. So my B, I said, is -5, my A is 6, and my C is -7. So notice I have 2 negatives there. That's going to make a positive. So I have 4 times 6 times 7, really. So that is going to get me a positive 168. And then I'm going to take -5 squared. Again, any number squared is always positive. So we both have positives here. So when I'm adding, I'm going to get a positive. So I have 2 real solutions. So that's when you ask how many solutions do you have? All right, and that's it.